Now for example 2, question number 1, on your lecture notes, we're gonna learn how to use the first derivative test in order to determine the relative maximum or the relative minimum for a graph. So we have a function given, fx is equal to 4x cubed plus 9x squared minus 12x plus 13. Find all the relative maximum and the relative minimum points of fx. Okay, so first we start with finding the first derivative of fx, because we know that at the relative maximum or the relative minimum, the value of f prime x, or the first derivative, is equal to 0. So f prime x is equal to 12x squared plus 18x minus 12. So when f prime x is equal to 0, 12x squared plus 18x minus 12 is also equal to 0. And then simplify first, so we get 2x squared plus 3x minus 2 equals 0. And then we can factorize that. So we have 2x and x, and then minus 1 plus 2. So we have x equals 1 over 2 and x equals negative 2. And now let's find the corresponding y coordinate for all the values of x. So when x is equal to 1 over 2, f1 over 2 is equal to 4 times 1 over 2 cubed plus 9 times 1 over 2 squared minus 12 times 1 over 2 plus 13 equals 39 over 4. And then when x is equal to negative 2, f negative 2 is equal to 4 times negative 2 cubed plus 9 times negative 2 squared minus 12 times negative 2 plus 13, which is equal to 41. So the coordinate of the relative maximum or minimum, we don't know yet whether which one is maximum, which one is minimum, but we do have the coordinates. So the coordinates are 1 over 2, 39 over 4, and the other one is negative 2, 41. And now we're going to use the interval table in order to identify the change of shape or the change of the gradient along the graph from negative infinity up to infinity or positive infinity value of x. So first we need to state the interval for x. On the left hand side it would be x is between negative infinity and negative 2, and the second one is x is between negative 2 and 1 over 2, and the third one is x is between 1 over 2 and positive infinity. And note that the values of x here, which are negative 2 and 1 over 2, are the values that we obtained from our previous calculation. So for each range or for each interval, we're going to take one test value. So for the first one, let's take negative 3, and the second one, let's take 0, and the third one, let's take 1. So the first one, we're going to check the value of f prime x, or f prime negative 3, which is 42. So it is a positive, that means the gradient is positive or inclined to the right, so we put the sign of the gradient there, which is positive. And the second one is f0, so the value of the first derivative when x is equal to 0 is negative 12, so a negative, which is inclined to the left. And the third one is f prime 1, which is 18, so a positive. Therefore, from all the signs that we have obtained here, we can know, or we can determine the shape of the graph as it moves from negative infinity to the positive infinity values of x. So for the first one, it's inclined to the right, the second one is inclined to the left, and the third one is inclined to the right again. So if we were to sketch the graph, this is how it's gonna look. So this is the relative maximum and this is the relative minimum. So from our calculation just now from the table, we can say that the relative maximum is located at negative 241 and the relative minimum is located at 1 over 2 39 over 4. So let me put here relative maximum, and here is relative minimum. So as we can see here, this is where f prime x is greater than 0 or positive. This is where f prime x is less than 0, which is negative, and this is where f prime x is greater than 0, which is a positive. So in conclusion, we can say that therefore the relative maximum is at negative 241 and the relative minimum is at 1 over 2 39 over 4. So that's all for example 3.